Well, hey there, good people. If you're watching this video, it's because you want to learn a little something about how we're going to set up our lab for lab number 1. Now, normally, I don't make these kind of videos for lab setups because I pretty much just explain it in class and you're here in class to do it. The reason why I decided to do one today is because lab number 1 is the most significant lab in terms of just like the new content that you have to know and understand and the new skills that you need. And because there's so much, I decided let's just make it a quick video so we can get this information out to everybody as efficiently as possible. Okay, let's talk a little bit about lab 1. Before you watch this video, please make sure that you have printed off the lab number 1 sheet. Otherwise, this will not make any sense to you. Please make sure that you've also read the lab number 1 sheet so that you kind of understand the general gist of the concept of the lab. Here's the idea of the lab. We have a cart, and we know that in this unit, we are studying constant motion. In other words, we're looking at when things are moving at a nice constant velocity. The whole point of this lab is to create graphs of constant motion. Now, I'm going to shift this slightly. Okay, now, when we create these graphs of constant motion, you're going to be looking at 2 graphs, a position versus time graph and a velocity versus time graph of constant motion. In order to create these graphs, you are going to need position data or displacement or distance data, and you're also going to need velocity data. The whole goal is to push this cart at a constant velocity and then take data from it. Here's the problem. You'll notice that if I push this cart at a constant velocity, it unfortunately doesn't stay very constant for very long. Did you see it slow down? That's because it did. The problem is that friction in the wheels, mostly in the bearings of the wheels, will slow down the cart, and so the cart won't travel at a constant velocity. If you want to get this cart to travel at a constant velocity, you're going to need some sort of force that overcomes friction that can pull this cart just as hard as the friction pulls back on it. In order to do this, what you're going to do is you're going to take a little piece of string here. Wow, this computer is so laggy. I hope that you can still see and hear okay. Okay. Okay, so here's what you're going to do. You're going to take this little string here, and you're going to tie it around your cart. The way that you're going to tie this string around your cart, let me show you. Here's the front of the cart. You're going to take this little string right here, and you're going to put it around the cart like this. Then do you see how there is a little loop that is all, I don't know if you can see that. Do you see how there's a little loop that's already tied in the string? Please do not make new knots in my string. What you'll do instead is you'll take the other end of the string, and you will thread it through the loop, just like this. Then you'll take, now you can see I have a loop. You'll take that and you'll slide it over the front end of the cart, just like this, and pull it nice and tight so that you have something that kind of looks like that. Okay, now here's what you'll do next. You'll take the other end of the string here, and you'll attach onto the other end of the string one of these weights. So you'll take a little weight, you will hook it onto the little loop on the other end of the string, and then you can see, here's my table. Sorry again for this camera situation. Here's my table. What you're gonna do is you're going to hold the mass off the end of the table attached to the string. Then the string with the mass is going to fall. When the string with the mass falls, it'll pull on the cart. I'll show you what this looks like. I'll start with something big so that you can see how it works. We'll start with 200 grams. You take the string on the end here. When you lower it, wait, I can do it. Okay. When you lower this string off the edge of the table like this and let it go, it'll pull the cart forward. That's the idea. The problem is, if you just saw, when I put this sized mass on the end, it will actually cause the cart to speed up, and so it's not traveling at a constant velocity. That's because the force of the weight of this mass is stronger than the force of friction, and so it makes it speed up. We don't want our cart speeding up. We want our cart traveling at a constant velocity. So what you have to do is you have to find the mass that is the perfect size so that when you put it on the end of the string and hang it off the table, it doesn't make the cart move. like that. That's probably too much. You want something that when you hang it off the end doesn't make the cart move, but also something where if you hang it off the end and it doesn't make the cart move, if you give it a small shove, then the cart will keep moving without slowing down. That's the idea. So the first task of the lab will be to find the perfect size mass to overcome friction. I'll let you do that. When you find the perfect mass, once again, what you'll be able to do, the way that you know that you find the perfect mass is that the cart won't speed up and it won't slow down. It won't do either of those two things because it will have just enough force pulling on it to overcome the force of friction that's slowing it down. So you'll give it a nice tap and it won't slow down. It'll keep traveling at a constant velocity. Now, that is how you're going to get this thing to go at a constant velocity. But then you also need distance and velocity data. The way that you are going to collect distance and velocity data and time data is you're going to use this guy. This is what we call a tape timer. And it's a tape timer because it times and it uses this kind of tape. It's kind of just basically like paper. This is a little roll of paper. The way that this little guy works here is, you can see the cord was so nicely wrapped around. Oh, that was so lovely. When you plug it in and turn it on, I want to show you this up close. When you plug it in and turn it on, do you see how there's this little needle here? It looks kind of like a little screw, and then there's this little carbon disc here. This carbon disc, you know when people make carbon copies of things, like on like the official forms, and you like write it on one piece of paper, and then it automatically copies onto the other piece of paper? It's like an ancient technology. Well, this is a little carbon disc. So what you do is you take this little carbon disc. If it's not already on your tape timer, I'm going to show you how to put it on. So you're going to slide it onto your tape timer so that, do you see this little like, whoa, can you see it? Okay, do you see this little post right here? You want the little hole in the carbon disc here to go right on top of that little post. And then you're going to slide it so that it's underneath the little screw like this. And so that is what your tape timer should look like with your little carbon disc. Now it's ready to record. Here's what happens. When you turn this little guy on, this little screw will go up and down and up and down and up and down and up and down crazy, crazy fast. In fact, like 60 times every second kind of fast, insanely fast. What you'll do is you'll take a little piece of tape timer tape. We'll take a piece about this big. I'll distribute these to you, by the way. You'll take a little piece of tape timer tape like this, and you will thread it into your tape timer. Let me show you how you thread it into your tape timer. Do you see this little bar right here and this little bar right here? Wait 1 second. Whoop-a-doop-a-doop. Okay, sorry for that short interruption. We're back. Okay, do you see here how I have these little slots right here? There's like a little slot there and a little slot there. What you're going to do is you're going to thread the tape timer tape right underneath those little bars there. Let me show you. Wait 1 second. I can't. I needed my hands. Okay. Here we go. Here we go. So you'll thread it under the bars just kind of like this. Underneath both bars like this. So the way that it should go when you're looking at your tape timer is you should have, if everything's set up right, it should be a carbon disc on the bottom. Then your tape timer tape should be on top of that underneath these little bars here. And then your little screw should be ready so that when it pushes down, it will mark on the tape timer tape. So here's how it works. When this little needle bounces up and down here at 60 times a second, every time it goes down, it'll hit the paper and it'll hit the carbon disc. And when it does, it'll leave a little tiny dot on the paper. And so this acts as a little timer because you know that every little dot that you see on the paper came 1/60th of a second after the dot before it. So when you look at this piece of paper, you'll see a series of little dots. If you just like left the piece of paper here and I turned it on right now, you would see all these dots in one spot where it'd go brrrr, and it would just hammer this thing with tons of dots. Now, here's what you're going to do. Once your tape timer is all set up like this, you are going to take your tape timer tape. You're going to take a piece of actual tape. you are going to tape your tape timer tape to the back of your cart like this. Then your tape timer tape is all set up and ready to time the motion of your cart. What you'll do is you'll pull it back like this. Then, when you're ready to go, you'll have a mass on the end to overcome friction. You'll give it a quick push. First you'll start the tape timer. So the way that you do it on this one, they're a little different on each one, is you have a little switch here, so it needs to be plugged in. But you'll start the tape timer, you'll give the cart a little push, and as it goes, the cart will pull the tape timer tape through the tape timer back here. As it pulls it through, the little screw is going to be going brrrr, and it's going to be putting little dots on the tape timer tape. Then, when you're done, when the cart has stopped, by the way, please make sure you have a lab partner here who can catch the cart to keep it from becoming a projectile and flying off the table. But you'll have somebody here to catch your cart. Once you're done with your motion, you'll take the tape timer tape out, you'll untape it, and you'll look at the underside of it, not the top side, but the underside, the side that was touching the carbon disc. And when you look at the underside, you will see a series of little blue dots on there. Now, you can't see mine because I didn't actually turn on the tape timer, so it doesn't actually have any data. But you'll see a series of little blue dots on the tape timer tape. Now, here's what I want you to imagine. 1 second. Bum, 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 ba-dum, ba-dum. Okay. Here's what I want you to imagine. Sorry, let me get out my little board here. Let's go here. And let's make this small. It always starts out so big, and then I make these really big, obnoxious marks on the paper. Okay. Here, imagine, is a piece of tape timer tape. Well, I think I did that okay. That's not great. Let's try one more time. Sorry, we can do it. Oh gosh, how did that get so much worse? Okay, sorry. I can do it. I can't do it. If only we could go back to the way that things were before I undid all of them. Okay. Yeah, gosh. Okay, wait, let me just try. I'm just trying again up here. Okay, that'll do. Pretend that this is a piece of tape timer tape. What you'll see is that this computer is sitting on a chair right now and it's swivelly. Let's move it so that you're not like swiveling around. Okay, what you'll see is that if the cart was just sitting still in one place, then the tape timer would be going, and it would be putting a ton of little blue dots in one place. But then, if the cart is moving and the tape timer tape is sliding through the tape timer as it's putting dots, then it'll put a dot here. But then the tape will move, so then it'll put a dot here. And then the tape will move, so then it'll put a dot here. And then the tape will move, so then it will put a dot here. And then the tape will move, so then it will put a dot here. Now here's what's magical about the tape timer tape. Do you see how the tape timer tape is recording both time and distance? We know that because the tape timer creates a little dot once every 60th of a second, that the amount of time between this dot and this dot is 1/60th of a second, which if you do a little bit of math really quick and you do 1/60th of a second, oh gosh, isn't that 0.067 seconds? It says it in your lab. I forget what it exactly is. Oh gosh, I'm literally going to get a calculator and find out really quick. Give me 2 seconds. If it's actually... Okay, yes, we're recording. I think we're recording. Okay. Wow, so like 2 seconds after I got up, I realized I could have done this in my head. But why do it in your head when you can do it with a calculator? That's what I would say. Okay, so here we go. We got 1/60th of a second is 0.0167 seconds. So the amount of time between each dot is 1/60th of a second. It's 0.0167 seconds. And you can assume that it's good out to this many sig figs. So that's our time between dots. Then our distance between dots here is the distance that the cart traveled in 0.0167 seconds. So this was how much it traveled in the first 0.167 seconds. And this was how far the cart traveled in the second 0.167 seconds. And this was how far the cart traveled in the third 0.167 seconds, and so on and so forth. So you can see how much distance the cart went in each time interval. Now, if you want to know how far the cart traveled in, like, I don't know, 1 second, then you would need 60 dots. And you could count from 1 dot to the 60th dot and measure that distance, and that would be how far the cart traveled in 1 second. You can see here how the tape timer tape is recording both time data and distance data at the same time because it's showing how far the cart traveled in the 0.0167 second time interval. Isn't that great? It's super, super awesome. Hey, give a quick guess, and then I will draw a little diagram for you after I erase this one. But give a quick guess. If your cart were going at a constant speed, what would your dots look like on your tape timer tape? If your cart were going at an increasing speed, it was getting faster and faster and faster, what would your dots look like? If your cart were slowing down over time, what would your dots look like? Go ahead and think about it for a quick second, and then I'll draw you a picture. Oh my, GOSH, the way that I can't draw straight is just crazy. Oh no, I have the working symbol of death. Sometimes the working symbol comes up, and if it never goes away, then I literally have to pause the video and restart the Canvas app on Chrome, and then that's the only way to fix it, which I think might be our situation right now. So I'm going to go ahead and pause the video, refresh the Canvas app, and then I'll be back with you in, to you, it's going to be no time at all. Okay, see, wasn't that magical? Look, it all got fixed. Okay, now look at this guy right here. If your cart were speeding up, then the dots would be getting further apart because your cart would be getting faster and faster and faster. So the dots would be spreading out because they're covering more distance in the same amount of time. So your dots would look like all clustered together from when it's not moving. Then they would be close together here. And then as it gets faster and faster and faster, your cart is covering way more distance in the same amount of time. And so your little distances here between your little dots would be getting bigger. If your cart was slowing down, it would be just the opposite. You would have here, like here's the start where it's not moving yet. And then all of a sudden, as it starts to move, you would start going really fast, covering a lot of distance in a certain amount of time. And then gradually you would start covering less and less and less distance in a given amount of time. Well, so this is a picture. You can see actually how your dots on your tape timer are not just like giving you distance and time data. They can also show you about what happened to your cart, whether your cart was speeding up or whether your cart was slowing down. Your goal in this lab, if you choose the perfect mass to overcome the force of friction, your goal is to have a cart or to have a tape timer tape where your dots are perfectly evenly spaced. In other words, you're always covering the same amount of distance in the same amount of time for every time interval. That's your goal for this lab. Then you're going to see if your graphs reflect constant motion or if they show that your graph was speeding up or that your cart was speeding up or that your cart was slowing down. So that's how you interpret your tape timer tape. When you record data, what you'll do is you will measure the distance between each of your little dots, starting at the first significant dot. We'll call this first significant dot here, dot 0. Now, here's going to be the problem, is on here on this picture, I drew my dots all nice and spaced out, nice and wide, but likely your cart isn't going to be going fast enough for you to really have a good amount of space in between your dots. So really your dots are going to look more like this. Something more like that. And then like that. And more like that. That that is really, really hard to measure the distance between this dot and this dot, and this dot and this dot, and this dot and this dot. So what you'll do instead is you'll measure the distance between every 10 dots. So you'll count this dot as 0, and you'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 dots, and you'll label the 10th dot. Then you'll count the next 10 dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and that's your 20th dot. Then when you record your data, you'll be measuring every 10 dots. So instead of 1 dot, which represents 0.0167 seconds, if you're measuring every 10 dot, well then 10 dots represents 10 times that amount of time. So 10 dots would represent 0.167 seconds. So you'll measure how far your cart went in 0.167 seconds, and that will be your first time interval. Your second interval will be how long it went in the next 0.167 seconds, which is the next 10 dots. That just makes it way easier to count dots in this lab. Otherwise, counting dots and measuring the distance between them is going to be nearly impossible for you. So that's a little simplification that we'll make. When you count dot 0, again, you're going to have a whole cluster of dots that all seem to be so close together that you can hardly distinguish between them. That cluster of dots is when your cart is not moving and it's just sitting still. And so that's not your 0th dot. Your 0th dot is the first dot that feels distinguished, set apart, as though it has moved away because the cart has actually moved. That's how you know when to start counting dot 0. And that is pretty much all that I can think of for this lab, but let me look at the lab one more time and see if there are any other notes that I want to make for you. Are we rolling? Yes. Okay, one last note for you, and then I think that will be all my notes. Everything else you can kind of find as we work through the lab together with you here in class. The last note for you, when you're choosing what little mass size you want to go on the end of your string here, you should be making that choice while the tape, or while your cart is connected by the tape timer tape, like through your tape timer. You should be making decisions about what is going to overcome friction while all of this is set up. The reason why is because as the cart drags the tape through the tape timer, this is going to create a huge source of friction. So what you should do is you should have your cart set up with your tape timer, just like this, all set up and ready to go. Don't turn on the tape timer, but just go ahead and while it's all set up, put a little mass on the end that you think might be a good size. Give it a little shove. If it slows down and stops, that means that you have too much friction and not enough mass on the end. So increase your mass size a little bit. If you shove it and it gets faster and faster and faster as it goes, that means you have not enough mass on the end. So go ahead and try something else. That means you have too much mass on the end, so go ahead and try something smaller. But do it while the cart is connected to the tape timer. And I do believe that is pretty much all for my instructions for you. Please let me know what questions you have, and I hope you have a wonderful rest of your day. Bye, good people. I can do it. Okay, yes. Bye, everyone.